Hey guys, what's up and welcome back to another video. So here we'll be going through a complete walkthrough of the IGCSE Edexcel Maths A Paper 1H. Okay, and this occurred in the May-June 2018 series. And for you guys who don't know, this is exclusively the higher tier for the new spec. Okay, so if you're not sure which is the new or old spec, firstly the new spec for higher starts from 1 now. So it's not 3H, 4H, it's 1H and 2H. Plus the coding is different. It's now 4MA1 instead of 4MA0, which is the old spec. Anyway, without further ado, let's go, yeah? So I'm going to go through every question to the best I can, and I've already put solutions down for some of them, especially the long ones, just to make sure that it's 100% correct. Okay, so if you see anything that looks a bit odd, hopefully it shouldn't be, just let me know. Anyway, as for formulas, you need to know the arithmetic series, and this is going to be quite important for probably a later question. Another formula I want you guys to add to your formula booklet is this UN formula, which is similar to the sum formula except there isn't a 2. So it's a plus n minus 1d. This tells you the position of the nth term. So this is the nth term formula. Okay? And the rest is okay. You know, we've got trigonometry, you got they don't give you nothing actually. They give you triangle properties, quadratic formula, all the important stuff, yeah? They don't give you area and circle stuff, but don't worry, we'll put that as we go. Anyway, without further ado, we've got 20 questions and let's crack on. So, number 1. The table shows information about the weights in kg of 40 parcels, okay? So this tells you, for example, the parcel weighs between 0 and 1 kg and there's 19 of them, and so on. Write down the modal class. Now, modal is literally the mode, meaning the most popular or the most common. And clearly, the most common is 19 parcels between 0 to 1. So the modal class is 0 to 1, okay, because there's 19 of them. So stuff like this is just straightforward. And now for part B, it says work out an estimate for the mean weight of the parcels. So the mean weight is straightforward. You literally need to find the total fx, so I'm going to write this column now. And fx is found by multiplying the frequency with the midpoint of the parcels. So let's go ahead and write the midpoints here, yeah? So the midpoint between 0 to 1 must be 0.5, 1 and 2 is 1.5, and then so on, 2.5, 3.5, and 4.5. And now all you do is multiply against the frequency. So for example, in your calculator, write 0.5 times 19, and you should get 9.5. And then 1.5 times 12 should give us 18, and so on, yeah? So I've already actually calculated the final result already, just to show you again. I got 1.4 kg, so we need to get to this answer, yeah? And then 3.5 times 2, so that's 7, and last one 9. And now here we of course add them all up. So in your calculator, if you add all of these up carefully, you should get, so bear with me guys, so 18, 12.5. So have a go while we're doing this, yeah? See if you get the same result. And if you do, you should get 56. Now, because we know there are total 40 parcels, this means that the mean weight should be 56 over 40. And if you put 56 over 40, and hopefully you should get, yep, 1.4. And that's it. So this means 1.4 kg, which makes sense because if you look at the way the parcels, you can see that most of the parcels lie between 0 and 2. So because 19, 12 are the vast majority of them. So it makes sense for the answer to be somewhere between 1 and 2, which 1.4 fits nicely. And yeah, that's perfectly it. So let's move on to number 2. Okay, this one's quite easy as well, but you just have to be careful. So let's have a look. So there are some people in the cinema. Now 3/5 of the people in cinema are children. So this means, guys, that 2/5 must be adults. Yeah. So write this down right now. Okay, just to make that distinction clear. Now for the children cinema, specifically the children, for every girls to boys, there are 2 girls to every 7 boys. Okay, so if you just to simplify this ratio for a second, we could say that for every 1 girl, there are 3.5 boys. Okay, this will help. Usually for these type of questions, they help. So for every 1 boy is for every 1 girl is 3.5 boys. Okay, so that's why half in the ratio, simplifying it. Now we know that there are 170 girls in cinema. So if there are 170 girls, and we know that for every 1 girl there are 3.5 times many boys, we can say that there are 3.5 times 170, which will give us a number of boys. So in your calculator, you're going to write 170 times 3.5 to work out the actual number of boys, which means there are 595 boys. so far in total, that the number of children we have would be 170 plus 595, which would give us 765 children. Now, this is pretty good because this means that because we already did a lot of maths, we can say that 765 children represents 3/5 of the people. Okay, so this helps a lot. Work out the number of adults in the cinema. Well, we know that 2/5 of the people are adults. So if we know 3/5 of the people are children, to make your life easy, first find 1/5 by dividing by 3. So divide your answer by 3 to get 255 people, and then timesing it by 2 to get 2/5 of the people, which are of course adults. So these are the adults, and this was the children. And then you should get 510. So 255 times 2 is 510. It makes sense. So this represents 2/5 of people. This figure here represents 3/5, and we should get 510. Perfect. Yep. So if this question was good, let me know. And if you guys are struggling any bits, just write in a comment below, and I'll try and help you through as soon as I can. Okay, next one, number 3. Oof. All right, these ones are easy. So simplify y to the power 5 times y power 9. Well, if you're times, you just add the powers. So 5 plus 9 is 14. Next one, simplify 2m cubed all to the power 4. This one, all this means that you stick the power 4 to both these numbers. So it'll be 2 to the power 4 and m3, and you just literally stick on like that. M3 times 4. So 2 to the power 4 in your calculator, because of course it's a calculator test, it will give you 16. And then 3 times 4 is 12, so it's m to the 12. Seriously, make your life easy. Don't get too complicated, these questions. They're usually quite straightforward. Next one. Solve 5 times x plus 3 equals 3x minus 4. Now for these ones, always expand the bracket, yeah? So times 5 to the bracket, you get 5x plus 15, and then copy the rest. And now throw all the x terms on the left. So if you got 5x here and 3x, to throw 3x across, you just subtract it. So it'll be minus 3x, so you get 2x here. And then throw plus 15 across, you get minus 15. So minus 4 minus 15 is minus 19. And lastly, to separate the 2 from the x, just divide it by 2. So this means x equals minus 19 over 2. And that's exactly what I got earlier. Okay, and let's move on to D. Okay, so factorize this quadratic. Now, when you see something in this, like x squared plus an x term with a number, always think of this as 2 bracket problem, yeah? So get the 2 brackets ready. And because it's x squared, we know there's going to be x times x in the beginning. To easily, factorize this, think of 2 numbers that multiply to make 24 and have a sum or difference of 2. So 2 numbers that multiply to make 4, let's just 24, let's think. So we got 8 times 3. But that doesn't seem to have a difference of 2. We also have 12 and 2. Anything better? Yeah, 6 and 4. So 6 and 4 clearly has a difference of 2. So you put 6 here and 4. To get plus 2, it must be plus 6 minus 4. And that's it. Easy. That's factorized. And now hence solve that equation when you set it to 0. So if you notice, this quadratic is the same as the first one. So just make that equal 0. So I'm just going to do it here for the sake of it, yeah? So when you do this, and this is just a quick way, if you got x plus 6 equals 0, then x must be negative 6. So flip the sign. If you got x minus 4 equals 0, then x can also be plus 4. But in exam, just write x equals 4. We don't need to write plus sign. That's it. Just literally flip the sign and make x equal it. That's literally all what you always do every single time. And let's go on to number 4. So for this Venn diagram, I put a couple notes here, yeah? If you get this U sign, it means union. It means the combination of everything in the Venn. If you get this N sign, think of N for intersection. Okay, not N, so intersection, why not? This means stuff that are in common for both. For example, the intersection of B and C would be 5. But the union of B and C would be every single element inside it. That's literally all it is. Now, let's go ahead and look at the question, yeah? So write down the numbers that are in the set A. So we just look at A, so literally the whole circle of A. So we have 1, 3, 2, 4, 12, and 6. So write down the numbers that are in set A. So we just write the list. So I'll put in numerical order. So you got 1, you got 2, you got 3, 4. Yeah, actually this is quite easy. you have 6 and 12. So yep, cool. Write down the numbers that are in set B uniting with C. So B union C. So everything in B and everything in C. So clearly we have 1, 3, 9, 7, 11, 5, and 10. Yeah, this one I'm not going to do in order. I'm just going to just list it here. Yeah, so 1, 3, 11, 7, 9, 5, 10. Did I miss anything else? Yep. So 2, 4, 6, 7. 2, 4, 6, 7. So it should be 7 digits here. Okay, yeah, that goes there. Now, Brian writes down the statement that when A intersects with C, you get something known as the empty set. So what this means, if you look at the Venn for a second, you can firstly see that A does not intersect with C. And this is actually correct. This means that this is not intersecting. So we say yes, it's true, because A does not intersect with C. Very simple. Keep your answers very simple. Now, one of the numbers in the Venn diagram is picked at random. Find the probability that this number is in the set not C. So this little C prime, this literally means not C. So try and focus on that little apostrophe here. So this means every element that is not in the circle C. So it's 5 and 10 in C. That means every single thing is not in C. So literally we just exclude these two. So we have how many numbers? So write on probability. So it's going to be, let's count. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of, and including these two, 12. So the probability that the number is not in C would be, of course, 10 out of 12. Or simplify, 5 out of 6. Easy. Okay, number 5, yeah? Now, write, oh, okay, all right. You know what standard form is, this is a nice way to wrap this up. Write 8 times 10 to the power 4 as an ordinary number. Just smash this in your calculator and you should get 80,000. Another way to understand this, if you don't use a calculator, this 10 to the power 4 means it should be exactly 4 digits after 8. And by digits, I mean if there are no other decimals, just write 4 zeros. So 4 zeros, yeah? If it's a whole number. If it's something like 8.1 times 10 to the power 4, there should be 4 digits after the 8, including the 1. So it'd be 8, 1, and then 3 more. As long as there are 4 numbers, yeah? Okay. Now, part B. Work this out, give your answer in standard form. Ooh, this is made for the calculator. I did this before actually, and you would actually get the answer if you just type exactly what says in the calculator. So let me just double check it as well. So copy this out carefully. You don't actually need to put the brackets for this one, but as always, don't risk it and just put the bracket in. And if you do that, you should get, actually no, forget what I said, put the bracket in, yeah? Because if you don't put the bracket, it's going to think you're doing something different. So put the bracket in. Ooh. And I got 0.0005. And then what this means, to convert the standard form, you have 4 digits before the 5. So this means 10 to the power negative 4. So 5 times 10 to the negative 4. That's how you calculate. You just count how many zeros before the digit. And yeah, and just to double check this right, let me just check my working out. So 3.5 times 10 to the power 5 divided by 7 times 10 to the power 8. Brackets there, yes. Yep, it looks good. And this is the answer. So guys, if this video has been helpful so far, let me know. Please give me a like, share with your friends, and otherwise, stay tuned for more. Okay, number 6. What do we have? So it says here that M, N, and P are points on the circle. So we've got M, N, and P with center O. And you can clearly see that we have a diameter here from M straight to N, cutting through the center. And we've got radius from M to O or O to N. Okay. And it says here that we've got a couple lengths, and it says here that angle MPN is a right angle triangle. So this is right angle, meaning if we had to find some lengths, we could use Pythagoras Theorem to find the long side, the hypotenuse. Now it wants us to work out the circumference of the circle. Okay, so circumference area, we're not actually given the formulas, but to make it clear, the circumference is always either 2 times pi r, where r is the radius, or the circumference can be written as pi times the diameter, d. Okay, and looking at this head on, it looks to me that it's easy to find the diameter, which is pretty much the hypotenuse side. And we can find the diameter by using Pythagoras' theorem. So let's call all of this length d, yeah? Once we find d, plug in the formula and then times it by pi and you've done it. So let's do it. So using Pythagoras Theorem, it's always going to be the short side squared times the other side squared equals the long side squared. So let's write this equation. 3.5 squared plus 9.7 squared must be d squared. Okay? And let's put this all in the calculator. When you do that, you should get plus 9.7 squared about 106.34 equals d squared, and then just square root your answer. And it comes to about 10.31 and so on. And that's about d. Now, plug in this value for d into the circumference formula. So it'll just be pi times your answer. So in your calculator, just type answer times the pi bun. And then you should get about 32.4. And they wanted three same figures. And that's it. Simple. Not really much to say here, is there? So let's look at 7 now. So it says here that Chang bought a boat for 160,000 Hong Kong dollars. That's quite okay price. The value of the boat depreciates by 4% each year. Okay, keyword. Depreciate means decreasing, yeah? And now, to do this, there's a very nice, beautiful formula to learn. It's always the original value times some multipliers, so 1 plus or minus a rate equals the new value. And of course, and because you're dealing with years, because it says work out the value of the boat at the end of 3 years, we just take a power through here, which is the number of years or times. Now, all you want to do is literally replace what we know. So we have an original value of 160,000. We know that it's decreasing by 4% per year, so it'll be 1 minus, instead of r, we write 4%. In your calculator, you should have a percent button. If you're not sure how to put it, just use the value of 0.04 instead of 4%, yeah? So one of these two. And then power to 3, and that's it, you've done it, and this will give you an answer. And when you plug this in the calculator, you should get, so I should really just calculate this. So I've actually already done it anyway, and I got about 141,558 Hong Kong dollars. Easy. I mean, these are giveaway marks. Literally giveaway marks. Now, next one. Jelena gets a salary increase of 5%. Her salary after the increase is 252,000 Hong Kong dollars. Again, same formula applies. So it's always the original value times 1 plus or minus some rate gives us a new value. And because there's no years involved, we just assume that it's blank. So it's probably 1 year. So we just replace what we know. So we know that the new value was $252,000. We know that it increased by 5%, so 1 plus 5%. And we're trying to find the original value, so let's just keep it OV. And now to find it, all you want to do is literally just make OV the subject. And by doing that, just get 1 plus 5% on the other side. And that's by dividing. So we can say, therefore, the original value is 252,000 over 1 plus 5%. Smash this in your calculator and you should get 240,000. Easy, seriously. These questions, I mean, this formula is very nice because it actually breaks everything down in a very simple way, and it's always the same. If you have years, you put power. If there's no years, you just work out what you want, OV or NV. Pretty okay. Now, let's move on to the next bit. Okay, 8. So we got A and B, which is given by some product of prime factors here. And it says here to find the highest common factor and the lowest common multiple. Now, quick tip here, quick tip. When you're trying to find the either of these two, I recommend that you always use Venn diagrams. Now, the reason why is because with Venn diagrams, it pretty much tells you how to find everything. For example, the middle area is actually known as the intersection, which is the highest common factor. So wherever goes in the middle is HCF. But wherever you get in all three segments will be the LCM. So let's have a go. We'll do this as we go. So looking at A and B, let's see what they both have in common. So I'm going to start with 7s. They both have at least, 3 powers of 7. So we can put 7 to the power 3, but B has an extra 7. Now 5, looks like only A has 5. 3, well, they both have a 3. I mean, A has 3, so they both have 3, so put it in the center. But then A has an extra 4 powers of 3. So B has only 1 power of 5, and A has 5 powers of 3. And lastly, what do we have? B has 2 to the power 3, and that's it. So we pretty much have everything. And therefore, to write down the answers now, we just look at the Venn diagram and we realize that the middle part, the intersection, is the highest common factor. So that means the HCF is 3 times 7 to the power 3. You can put this or write the values, totally up to you. I'm not too sure because the mask ain't out yet. But anyway, I'll probably put this and the answer underneath. Now for the LCM, is literally every single element. So it would be 5 times 3 to the power 4 times 7 to the power 3 times 3. It's literally every single element. All of this is the LCM. And just collecting it nicely, I'll start with the smallest. So starting with 2, we have firstly 2 to the power 3 times, and if we look at the 3's, we have 1 3 here and 3 to the power 4. And if we collect them, we have 3 to the power 5. Looking at number 5, we only have a single 5. And looking at 7, we have 7 to the power 3 and 7. So that's 7 to the power 4. That's it. Okay, part B now. Oof. So given that the HCF for B and C is this, and the LCM of A and C is that, find the values of P, Q, and R. Okay, and P, Q, and R is actually in the C expression. Now, quick tip. This one can look a bit tricky, but really it's not. It's just about how you go about it. When you have the LCM, always use that first, okay? Always use this first. The reason why is because the LCM only cares about the highest power out of the two options. So looking at A and C, for example, we have 2 to the power 4. A does not even have 2, but C has 2. That means if the highest power is 4, that means P must clearly be 4. So we can say so far P is 4. And now let's look at the next one. We've got 3 to the power 5. C does not have 3, but A does. And clearly we can see 3 to the power 5. So that's actually checks out. And now next one, 5 to the power 2. A has only 5, and this is 5 to the power 1, whereas C has 5 to the power Q. That means Q must be 2, because remember, we want the highest power out of one of the two options. And since it's 2, Q has to be 2 for this to actually be true. So Q is definitely 2. Now, the last one isn't that obvious. We got 7 to the power 3. However, A already has 7 to the power 3. But C could be 7 to the power 3 or less. Remember, this is the highest power of these two. So that means we can't assume that R is 3 or 2 or 1 or even 0. So it has to be, so we have to look at now the HCF. Now the HCF just cares about the minimum that what they both have at least. Now it tells us that of B and C, they both have at least a single power 7. This means R must be 1, because for this to be true, this has to be only a single power 7. If it was 2, then it would say 7 power 2. So R must be 1. And that's it. That's literally everything done here. So we should have 4, 2, and 1. Now, if you guys understood this, please let me know. And if you guys want another deeper explanation on this, again, just, pop a comment down and I'll try and help you as soon as I can. Anyway, let's move on to 9. So this one, I've already jumped in and gone ahead and done this because this question is a bit lengthy. And that is really noticing the fact that we need to calculate the perimeter of this whole shape. And that is the length around the star. Now, to do this, you'll notice that we've got loads of right angle triangles here. And we're given a simple one, just with some information already. The trick for these kind of questions is to always work out every single length of these triangles first, and then figure out how to play it here. So let's go ahead and work out the lengths of this triangle first, before we look at the shape, the big shape altogether. So the first thing I always recommend is to label this size. So I'm going to call the adjacent length here X and the hypotenuse Y. And just a quick recap. The length opposite the angle of interest is known as the opposite. Yeah. So again, opposite of opposite. This side is the adjacent. Oops, ADJ, and this is the hypotenuse. So when we look at this shape here, we always have to think SOHCAHTOA. Yeah. So SOHCAHTOA. Now, what I'm going to do is use firstly SOHCAHTOA to find one of the sides, and then use Pythagoras Theorem to find the other side. So right now I'm going to say, okay, let's find the opposite. Let's find the value y. And to do that, we already have one information, which is the opposite. So we can call this one O, and the value y, which is h. So using O and h, that's going to be SO, because SO has O and h. So to write this as an equation, SO is always written as the sine of the angle, i.e. 72, equals the opposite over the hypotenuse. Same with the rest. This will be cos equals adjacent over hypotenuse, tan equals opposite over adjacent. So in this case, the opposite over hypotenuse, so the opposite is 12.8 over the hypotenuse, which is y. So just make y the subject now. And to do that, just times y across and smash sine 72 to the left. So y equals 12.8 over sine 72. Put this in your calculator, and I've already found the lengths, by the way. If you put this in calculator, you should get 13.459. So update the values here and write about 13.459. My tip usually is to not round it off, but because they want actually 3 significant figures, just do it to, I don't know, 3 dp for now. Now let's go on to the next bit. Yeah, so now we found this value, so we can actually delete all of this information. We can just work out the third length, which I said was x, right? And to use Pythagoras Theorem, it's always for example, the short side squared. So a, for example, in this case is x squared plus 12.8 squared must equal the hypotenuse squared. So essentially it's like this: x squared plus 12.8 squared equals the long side squared. Okay, so nice and easy. So let's go ahead and make x a subject here. So subtract 12.8 squared across. So you get all that information minus 12.8 squared. Smash this in the calculator and then square root the answer, and you should get 4.159. Okay, so I'm going to use this triangle here because just to speed time up a bit. Now let's go back to the main information here. So the main shape. So now to work out the perimeter, you'll notice that I put some red lines and purple lines. Well, the red lines, if you can see, is actually identical to this length over here, the opposite. Because you've got the right angle here, and if you just twist your head a bit or just look at this triangle here, this triangle is the same as this, must be 12.8. So all the red bits are 12.8. Okay, typically it's always best to keep the answers in unrounded form. The only reason why, if we go back to these values here, so I made just a few changes, by the way, and I've got the exact answers and stuff. For this particular question, when you actually work out with the rounded forms I gave you, you might get an answer which is about 110.5, and when you round it up, you'll get 111, and that would be a problem because this is the exact answer. So actually, it's so close to 110.5, Edexcel might give you a mark for that anyway, and the correct answer is actually 110. They might say 111 is also fine, but yeah, generally speaking, keep the unrounded form. So in your calculations, when you want to work out this short length, which is, by the way, the difference between the hypotenuse and the adjacent, because you can see you got the adjacent bit here and the hypotenuse. So this is essentially y minus x. All you want to do is usually type this into your calculator minus this value here to get a very small answer, and then you want to times 5 lots of it. So our perimeter therefore is going to be what? 5 times 12.8 plus 5 times whatever y minus x gave us, the difference of these two. And putting this in your calculator, summing this up in total should give us about or exactly 110 point so on. And to 3 significant figures, we look at the fourth value here. It's less than 5, so must be 110. So the cumulative frequency graph shows information about the length in minutes of each of 80 films. Okay, so just for those who don't know, a cumulative frequency is basically adding up all the frequencies as we go along. So that's why from the beginning, if we look at the length in minutes, we can say for up to 80 minutes, no films are watched. But films that lasted for, let's say, 100 minutes, we can say that there were definitely up to 15 films. So of course, films up to 140 minutes, that accounts for every single 80 films. So that's how it goes. It's always going to increase. Cumulative frequency graphs never go down. They always go up, up, up until they reach the maximum. So let's look at the question now. So use the graph to find an estimate for the interquartile range. So this is the IQR, guys. Now this is just simply the upper quartile minus the lower quartile, hence the name interquartile. Now if we look at it carefully, we know that there are 80 films. That means the upper quartile is of course going to be the third quartile. So in your calculator, we need to find the third quarter of 80. So literally write 3/4 times 80 and you should get 60. So looking at the 60th. And to find the lower quarter, we need to find 1/4. And 1/4 of 80 is, well, 20. So we're going to try and find out the actual difference. So all you have to do is go across this line, hit the 60 value and see what value that is. So according to the graph, if you look carefully, that looks like it checks out what? 123. So let's just make a little point there, yeah? All right, 123. Now, as for 20, if you go across, it looks like it's bang in the middle. It's bang in the middle between 100 and 105. So I'll say about 102.5. So always mark this down, 102.5. and therefore the IQ are just 123, take away 102.5. So let's put that in a calculator. So 123 minus 102.5, and you should get about 20.5. So that's it. That's literally the range of minutes between the third quarter and the lower quartile. They'll probably accept answers between 20 to 21, just in case, but don't hold me to it though. Now let's go on to the next part. So Claire says more than 35% of these films are over 120 minutes long. Let's check this out. Let's find out 120 minutes. So 120 is there. If we go up, it checks over there. And if you go across here, that checks that over here. And what's that? I think it's in the middle of 15, 60, isn't it? So we got 1, 2, 3, 4, 5. So this tells us that up to 55 films have a length of 120 minutes. But we care about over 120 minutes. So we're talking about after it. So the first 55, of course, have movies that last up to 120 minutes. But if they're over 120, that's going to be the remainder area. So that's going to be the remainder after. So it'll be 80 minus 55. So it'll be the 25 films not accounted for. So that's it. So if it's 25 films out of 80, let's see what percentage that is. So you got 25 over 80. And if you want to change the percentage, well, just times it by 100. Put this in your calculator. I mean, I'm doing this literally all from scratch, guys. And of course, I have checked the answers and stuff, but we have to check together. So I've got 31.25%. So yeah, so the answer is no. So is Claire correct? No, because only over 31.25% of these films are over 120 minutes long. So the answer is no, because of this. Yeah, so that's it. So that's this question done. And again, if you guys enjoyed this video so far, give me a like and let me know if you understand the explanation, yeah? Because sometimes we have to really thoroughly break it down. Anyway, let's move on to 11. So expand and simplify 2x minus 1 and so on. So these triple bracket problems are so easy. The trick is to always use FOIL on the last two brackets, or at least two easy brackets. And then once you tidy that up, use FOIL again with the new bracket and the first one. So let's do this out. So tip, copy the first bit, use FOIL on the second bit. So if you're not sure how to do it, it's always x times x, x times minus 5, and then 3 times x and 3 times minus 5. So what does that give us? X and x is x squared. X times minus 5 is minus 5x. And then 3 times x is 3x. Combine these two, you get minus 2x. And then 3 times minus 5 is minus 15. So just a quick and fancy way of doing it. Next, I'm going to change the color of my pen. We're going to use FOIL on the next bit. So 2x with x squared with 2x and then 15. And then do the same thing with 1 with the other 3. So that's literally it. This is literally the extended FOIL method. Now, timesing everything by 2x first, the second bracket by 2x, you should get 2x cubed minus 4x squared minus 30x. And now this is a nice, cool way of doing this. Always try and line it up by powers, yeah? So once you've done the first term, move to the second, shift it across. So here we're going to times everything by minus 1. So x squared times minus 1 is minus x squared. So again, write it below the x squared bit. Minus 1 and minus 2x is plus 2x. And then minus 1 times minus 15 is plus 15. So you can kind of see what I did here. I literally just lined up nicely. And when you do that, and you add them all up, you collect like terms. You got 2x cubed plus nothing is 2x cubed. Minus 4x squared minus x squared gives us minus 5x squared. Plus 2x minus 30x is minus 28x. And then plus 15. And that's it. Fully expanded. Trust me. Quick and easy method. I really recommend you guys follow this way. Now B. Solve this quadratic equation when it equals 0. Show you're working clearly. Okay, this one, tip. When you have questions like this and they say give the three same figures and it's quadratic, use the quadratic formula, yeah? Now, I cannot even remember if they actually give us the formula here because I've been used to doing the old papers and yeah, they actually give it to you. So here's our formula. So the solutions are always in this form. ax squared plus bx plus c. In other words, make your formula always equal to 0. And then everything is either a or b or c. And then smash into this formula. So if you guys don't already know, I recommend you try to memorize this anyway. So let's go back to the question. So let's see, what is it? Number 11, yeah? So let's have a look. So using the formula, we've got x equals minus b plus minus the square root of b squared minus 4ac over 2a. My students usually think of this as b squared minus Yasin, so my name, but think of it as a 4 instead. So putting all the values, looking at the expression, we've got 3x squared, so we've got a is 3, so a is 3, b is 6, and c is minus 5. And when you put this in, always wrap it around in a bracket, especially the 4ac bit. So we can say therefore x equals, so minus 6 plus minus the square root of 6 squared, which is 36, minus 4 times 3 times minus 5. So remember, wrap in a bracket over 2 times 3. Yeah, so have a go at this one. So be very careful when you enter it in, yeah? And then when you input all of this, you should get hopefully some decent answers. So let me have a look. Actually, no, you're going to get 3 significant figures. So I'm going to get, so putting this carefully and then using the plus solution, you should get something like, let's see, x is about 0.633. So again, 3 significant figures. And then when you use the minus buttons, remember the plus minus means first you put the plus bit, and then you just go back in the calculator and switch that plus to a minus. And then your other answer should be minus 2.63. Again, 3 significant figures. In other words, 3 numbers that doesn't begin with a 0. Okay, yeah, so easy so far. So 10, 11 haven't been so bad. Now here we go, 12. So diagram shows 2 straight lines drawn in a grid. Okay, so you got a straight line with this equation here and another straight line with that equation there. And you can see that they're intersecting here. So usually when they're intersecting, we can solve them simultaneously using simultaneous equations, yeah? That'll give us the exact coordinate. But here you can see this is intersecting at 3, 4. Now, write down the solution of the simultaneous equations. That means where did they intersect? Well, 3 and 4. Easy. Now, show by shading on the grid the region defined by all 5 of these inequalities. Okay. All right, here we go. So this one, you guys literally get your graph paper ready. We're going to try and do this. So have a look. So we've got 5 equations. They've already drawn 2 straight lines for us. So that looks like these last 2 here. Okay. However, they have not drawn x plus y greater than or equal to 4. Now, this is easy to draw. My tip is firstly make y the subject and just literally find 2 coordinates, plot it in, and then draw a straight line. For example, over here, let's say we make y the subject. So we have y equals 4 minus x. Remember, throw x on the other side. Make a nice little table, x and y. Plug values for x, easy ones. So for example, when x is 0, you get 4 take away 0, which is 4. When x is 1, you get 4 take away 1, which is 3. And that's your coordinates, 0 and 4, and 1 and 3. So plug it in, you got 0 and 4, so 0, 4 is there. And then 1, 3 is here. So here, so it's quite straightforward. It's literally just a simple straight line. So I'm not using PowerPoint this time. So oh God, that's awful. Yeah, I can't really draw a straight line with this tool. But anyway, that's the idea, yeah. And you can just literally extend if you want. So yeah, something like that. Now it tells us that x plus y is going 4. So now we've drawn the lines. That's perfect. So as for these 2 lines, this is easy. This tells you that x values need to be greater than or equal to 0. So we look at the x-axis, and it's greater than 0 when it's over here. So we're looking at values above the x-axis. In other words, we are not interested in this bit. Likewise, for y greater than or equal to 0, we're looking at the y values greater than 0. So here's the y-axis. When it's bigger than 0, we're looking on the right side. So we cross out the left. Remember, the left side is negative, so it doesn't count. So in this case, even though it says labeled region R, it's always good to cross out the sides you don't need, the areas you don't want, yeah? So again, guys, if you're not sure what's happening, drop me a comment. I'll try and explain it step by step again. So yeah, make sure you use a ruler as well, not like me, yeah? Okay, let me change the color pen. Now let's get to this bit. X plus y greater than or equal to 4. To get this right, I do something known as a true and false statement, yeah? So for example, x plus y is over here. So I should label this line. X plus y greater than or equal to 4. So we can see we've got this line here. So I will draw a line like this, call this side either true or false, and this is true or false. The tip is to pick a coordinate from either side and just think when it's true. Now it tells us that these 2 coordinates, x or y, the sum of them has to be bigger than 4. you can easily see is that if you pick a coordinate like 10 and 10, you get 20, which is clearly bigger. So this means this right side must be true. Then the left side of this line must be false. Because if you pick any coordinate on the left side, you'll get an answer which is less than 4, which is obviously false. That's it. Now for the next line, let's have a look. Which line should we do? Let's do the 3y one. So we're doing the second of this one here. So again, do the true-false statement. So we have to pick a coordinate from either side of this line. So let's pick, I don't know, let's pick again 10, 10 because it's easy to work with. Okay, so 10, 10. So we're going to see if this side is true or not. So using this coordinate, plugging in 10, 10, we're going to see if 3y is less than or equal to 2x plus 6. So when you've got 10 for y, you're going to have 30. Is it less than or equal? 2 times 10, which is 20 plus 6, so it's 26. So this is clearly false. So this means that this side was false. So we cross out the side on the other side of the line. Okay, so I hope you guys are getting it. If you already got it, that's good. But now we're going to determine if it's going to be this is true or this is true. So our final equation will be 4x plus 3y. So we're going to look at this line now and just pick a coordinate again. On the right side, I'm going to pick, I don't know, maybe this coordinate. So we're going to check if this side, the right side of this line is true. And this is what? 10, 3, yeah? So looking at the final coordinate and testing 10, 3, what do we have? So when x is 10 and y is 3, we're going to have 40 plus 9, which is 49. So is 49 less than or equal to 24? Nope, it's false. So I'm getting another false statement. So this means this side must be false. So that means this is gone. And all that is left is this little region here. So oops, don't want to make it that too long. So all that's left is this little region here. So this means this is the region that they want. Okay, and that's it. That's literally it. That's all you have to do for this question. I mean, it is kind of long and it's only worth 3 marks. You guys might have a faster method, but this is just a guaranteed way to get it right and not make mistakes. Well, I hope so. Anyway, let's move on to the next bit. Okay, 13. So L, M, and N are points on a circle, center O. QMT is the tangent on the circle M. So it's talking about this line right here. And tip, when you have a center and you have a radius connected to a tangent, it's always right angled. So this is always right angled to the center, yeah? Keynote. Now, find the size angle NOM, norm. So NOM is from NOM. We're talking about this bit. And this is easy. Basically, the angle at the center is always twice the angle of an angle at circumference. So wherever this is always 2 times this value here. So always think of this like shape like that, yeah? Or whatever. This is always 2 times that angle there. So if this is 27, that's 2 times 27. So it should be 54. And here's a proper definition. If you guys got a CGP book, and I highly recommend it, I'm talking about this point here, number 5. It says that the angle at the center of a circle is twice the angle of the circumference. And this is the exact answer you can use for your solution. So I want to just literally say this is going to be the answer we want. The angle at the center is twice the circumference. So angle at the center is twice the angle. So here's twice the angle at the circumference, i.e. twice 27 at the circumference. Okay. Oof, handwriting not that great today. Now next one, find the angle of NMQ. So again, look at this other problem. So NMQ, where do we start? So we start with N, go to M, and go to Q. So we're talking about this gap here. Now this one's a bit annoying because this one's actually part of something known as the alternate angle segment theorem. So what it tells us is that the angle over here between the tangent and the chord, so this is a chord, yeah, is equal to the angle on the other side of the chord, i.e. 27. So we're talking about this chord, and by the way, we're not talking about this angle here because firstly the angle has to hit the circumference. So wherever this angle is, this has to equal the angle on the other side of the chord, okay, which is here, the one that hits the circumference. And this is part of this property here. So it's best I just show you actually. Again, this is something you have to properly study. So the alternate angle segment theorem is here. So for example, here's the chord. You know, it looks quite different, but we're talking about a simple chord and a tangent. If you imagine this chord, it's going to be on the other side of the chord. So I always draw an arrow from here touching the angle. And we just say the angle between the tangent and the chord is always equal to the angle in the opposite segment. Done. That's literally all you say. So angle, so yeah, 27. Angle between a tangent and a chord is equal to the angle on the other side of the circumference, yeah? Okay, so yeah, so again, try and draw arrows bouncing off it. But yeah, I hope so far this is helping, guys, yeah? I mean, let me know, of course, like how you're doing with that. Now, let's look at 14. So the function f is such that fx equals 3x minus 5 over 4, okay? Find f minus 7. All right, this is easy. Just replace x with minus 7 and smash in a calculator. So it's just going to be 3 times minus 7 minus 5 over 4, okay? So I haven't put that yet. When you do this, you should get minus 5 over 4 minus 13 over 2. I mean, you can leave it as a fraction or a decimal, yeah? Let's double check. Yep, easy. Now, express the inverse function in this form. So the inverse function is, it's quite easy way to look at it. All you have to do is literally rotate the letters. So just imagine fx is y, yeah? So now all you have to do is copy this function now, but replace fx here with x, and replace all the x's with y. So be x equals 3y minus 5 over 4. That's it. So just literally invert these letters, yeah? Function that is y, call it x, replace x here with y. Now all you do is make y the subject. So to do that, firstly times 4 across, so clear the fraction. So you can have 4x equals 3y minus 5, and then add 5 across and divide by 3. So you should get 4x plus 5 over 3, and that's it. And that is your inverse. It's literally so easy. Now next one. The function g is such that gx equals the square root of 19 minus x. Okay, find the value of f g3. So what this means is that g3 has to go inside f. So my tip is firstly work out what g3 is. So replace this function with 3. So firstly g3 is literally the square root of 19 minus 3, which is square root 16, which is 4. I mean, I'm not sure if this is positive or negative, but I think for this case, let's just say plus minus 4 just to be safe, yeah? Okay, it says find the value, so I'm going to assume it's positive, yeah? Let's just assume it's positive because they don't really say anything. And then g3 is 4, then all you do is plug in the value 4 into the f function. So go back to f, replace 3x minus 5, replace x here with 4. So it'll be 3 times 4 minus 5. So it'll be fg3, which is now f4, which is 3 times 4, minus 5 over 4. That's it. And then wherever that is your answer. It's 4 minus 5 over 4. Yeah, and I got 7 over 4. Wait, is that right? Yeah, I think it is. Okay, not bad. Now, here's the final bit. So this is just your understanding. Which values of x cannot be included in any domain of g? So this is talking about when you look at this function, what values of x can we not use? Well, we're dealing with a square root function. And we should know that in the square root, you cannot have negative values inside. So essentially, looking at this, 19 minus x cannot be, well, less than 0, yeah? So it cannot be less than 0, okay? So what this means is that if you rearrange and make x a subject, you can say 19 cannot be, well, x cannot be greater than 19, okay? So we can say x. So which values can we not include? So values of x that are greater than 19. So it tells us that we need to simplify fully this expression here. Now, if you look carefully, I'm just going to zoom in here. We have a negative power. Now, before you look at anything else, when you have a negative power, what it means in terms of powers is that you do not put negative signs. You want a negative power literally means take the reciprocal. So flip it upside down. So all of this becomes y to the power 8 over 256 x to the power 20. And then you put, instead of negative, it just becomes a positive power of 1 over 4. And then you just apply the power rules. So what we do here, so here we're going to apply the power of a quarter to every single term. So we're going to have y to the power 8 times a quarter. So you just times it on. If you got a power, you just times the powers. We've got 256, that also has a power of a quarter now. And we're also going to have x to the power 20, which is times by a quarter. And then all you want to do is firstly put all of this in the calculator. So y, so 8 times a quarter, well, that should give us 2, y to the power 2. 256 to the power quarter, that gives us exactly 4. That's basically the fourth root of 256. And for the x term, 20 times a quarter is 5. Okay, and that's your answer. That's your simplified fully answer. Now, B. Express these two fractions as a single fraction in simplest form. Tip. So, don't know if we've seen this before, but if you have a fraction underneath like this, which looks like this, and it's a squared function, it could be something known as difference of two squares, dots. And when you do that, this is a double bracket problem. So let's have a look at it. So for the first one, if you've got 9x squared minus 25, what you want to do is whip out two brackets, a bit like this. And then realize that in order to solve this, we need to square root both terms. So the square root of 9x squared is 3x. Put that on both. Put a plus minus. And then the square root of 25 is 5. So you should get the same expression twice. 1 plus 1 minus. And then we copy the second fraction. Now, another tip here. See if you can simplify this, if you can factorize. You'll notice that from 6x plus 10, they both go into the 2 times table. So let's whip out 2. So we should have 2 times, and inside the bracket, if you factorize 2, you're left with 3x plus 5. Okay, now looking at this carefully, the only way to make this a single fraction is if we have the same common denominator. So the bottom half must be the same. And looking at both equations, this side has an extra 3x minus 5, and this one doesn't. Secondly, this one also doesn't have a 2. So the way it works, you need to times up and down by what's missing. So I'm going to change the color pen here. And I'm just going to go in and multiply this. On the left side, we need to stick in a 2. So timesing up and down by 2, this becomes a 2, and you can put a 2 there. Here on the right side, timesing up and down by 3x minus 5, all of this becomes 3x minus 5 up and 3x minus 5 down. And now we just combine the fraction. So we can combine the top half. So it'll just essentially be 2 minus 3x minus 5. And doing it carefully, so I'm going to work separately. 2 minus 3x minus 5. If you open a bracket, and this is the part you got to be careful, you got a negative sign. So you have to flip the signs aside. So it's going to become 2 minus 3x plus 5. And 2 plus 5 is 7. So 7 minus 3x. That means the final answer is going to be 7 minus 3x over everything you see, which is 2 times 3x plus 5 and 3x minus 5. Okay, so this was quite a big question, wasn't it? I hope this is the final step. I mean, looking at it once more, seems you just have to try and notice that you have difference of two squares dots. But anyways, let's move forward now. Okay, 16. So a frustum is made by removing a small cone from a large cone. Okay, so they literally took off the tip. However, they are mathematically similar. So all that means is that they're proportionally different. Okay, they have the same shape but just different in proportion. Now it tells us that the large cone has a base radius of r and a height of h. So let's go ahead and imagine this for a second, yeah? The volume of the frustum over the volume of the large cone represented by 90 and 125 parts. So if we consider that the volume frustum itself is 98 parts and the whole cone is 125, this means that the leftover bit, and let me just change the color, the small cone bit, guys, must be just a little 27 parts. Okay, it makes sense because 27 plus 90 will give us 125 parts. Okay, so that tells us that the volume of the small cone over the volume of the large cone has a relationship of 27 out of the 125 parts. Cool. Now, what does this tell us? Well, when you work with mathematically similar things, this tells us that the volume, that the scale factor in general are all related. So I pretty much like jot this down. When you work at lengths, you have, let's say that the ratio between the small cone and large cone is represented by k. This means that the areas between them is k squared, and the volume between them is k cubed. And by the way, the k's here are all the same. The only difference are the powers. So look at this number again. We're looking at the relationship between the volume between the small and large cone, which is this. So technically 27 over 125 equals to k squared, k cubed, I mean. That means if you want to find the lengths, and by the way, we want the lengths because height is the length, we can say that to find k, we can just literally cube root this, and that will give us about 3/5. So we can say now that the relation between the small cone to the large cone has a height of 3 to 5 parts. So what I'm saying here, if this had a height of 3 parts, that means the full length has a height of 5 parts. Okay. Now, if you look at the variable, we called it h here. So let me just get this 98. This means if the whole thing is h, this means the height of this part is 3/5 of h. Makes sense? So this is 3/5 of h, meaning the thrust in the remainder bit is 2/5 of h. And yeah, guys, that's literally it. I mean, I think we solved it. And then you get 2/5 of h. Yeah. So this one is a bit, I can't explain. I actually recorded this video at least 7 times, you know, just to literally explain the best way I can. So if you guys enjoyed my explanation, please give me a like or any suggestions or feedback. And otherwise, yeah, literally memorize these group of formulas, because this is actually going to help you a lot, especially this whole scale factor concept. Anyway, guys, let's move on to 17. So the diagram shows a parallelogram ABCD. Okay. Now it tells us that when you go from A to B, so this direction here, you travel 2 across the x-axis and 7 up the y-axis. So remember, this is x and this is y. Where if you go from A all the way to C, so you can literally just imagine it like this, you're going to travel a direction of 10 across and 11 up. Okay, easy. So point B has coordinates 5, 8. So let's put that here for a second. So this is 5, 8. Work out the coordinates of C. Well, let's just look at it again, yeah? So let's look at A to B. If it's 5 to 8 and you're traveling from A to B, so if you went backwards, you would have gone back 2 spaces and back 7 spaces. So back 2 spaces from the x-axis would be 3, and back 7 spaces from A to B, 1. Now if you're going from A to C, you're going to travel 10 across the x, so 3 plus 10 is 13, and 11 from y, so 1 plus 11 is 12. And that's it, 13, 12. So the point E has coordinates 63, 2, 1, 1. Okay, so point E so far, guys, is not on this diagram, yeah? Now, use a vector method to prove that the line ABE is a straight line. So, in other words, it's telling us that if we extend this line AB all the way to some future point, I don't know, E here, yeah, which was what? 63, 2, 1, 1. Let's write that down. 2, 1, 1. We need to show that we can make a straight line. Now guys, the only way to find a straight line is to basically show that these two lines have the same direction. Does that make sense? A straight line means you move in the same direction. So in general, the only way to prove that this is actually a straight line is that the length, for example, from A to B must be proportional to the length from A to E. That is, for every 2 steps you go across X and 7 steps up, it must be the same from A to E. 2 steps across, 7 up, as many times it takes till you get here. So so to write down formally, you could say, all right, we must show that A to E must be proportional to A to B. So that is, to work out A to E is basically going from this to that. And you can just work out the difference between the coordinates. So we can travel at least the x coordinate. You can do 63 take away 3. That gives us a vector of 60 on the x. For the y, just subtract the y coordinate. So 211 take away 1 is 210. Okay. We want to show that this is directly proportional to 2 across and 7 across, 7 up. And well, to make your life easy, let's have a look. You can see that if you just divide these two, 7 over 2, this is at 3.5 times your y-axis compared to x. Whereas 210 divided by 60 is also, well, 3.5. So the diagram shows a curve with equation y equals fx. So this is a typical quadratic curve. Okay, this is a U shape. the coordinates of the minimum point, as in the turning point right over here with X markers, is -2, -1. So here they want us to write down the coordinates of the minimum point of the curve of equation. In other words, they just want us to shift the graph wherever it tells us here. So according to part I, it wants us to do y equals a function at x minus 5. So basically, when they write in this form, x minus 5, you got to think of it as in you're solving for an x coordinate. You got to think of this as x equals plus 5. Okay? So what this means is that you shift the right by plus 5. So this curve, if it starts at -2, -1, it's going to shift from -2. If you add 5 across, over here to +3. So it looks a bit like this or something. And this should be 3 minus 1. So remember, only the x changes, so it'll be 3 minus 1. Now this tells us to half the function. So in other words, we should half the y coordinates. So if you had -1, half of -1 is minus half, or minus 0.5. And of course, the x-axis does not change. Okay, so next bit now. Okay, so the graph of y equals a sine x minus b plus c for this given curve is drawn in the grid below. And here they want us to find the values of a, b, and c. Okay, so first things first, with a sine wave, you can see clearly that the range is really messed up. Because from what we understand, and if you're not too sure what it looks like, it's always locked between 1 to -1, yeah, and goes back from 90, 180, 270, and 360. And of course, it's symmetrical as well. Well, not symmetrical, but it goes backwards too. Okay. Now, one thing to note is that if this had a height of 1 and -1, this means that the center is 0. But over here, it looks like it's from -1 to +3, so the center must be over here. So what I would always do is firstly draw the center line, just so you can actually see where it locks to. Now, doing that, you can kind of see that, you know, the height from 0 to 1 is 1, so the distance is 1 here and 1 here. Here you can see the distance is 2. So what this means is that the graph itself has been doubled. So a in this case is a scale factor. It's been scale factored by 2. So we know straight off the bat that a is 2. Okay. Next, you can see that the graph itself has shifted up by 1 because the center is always at 0. If you're going to double a graph, this would double to 2 and -2. But for some reason, it's kind of oddly gone to 3 and -1 is here. So it's kind of the whole graph is shifted up from the center. So we can say that for C, it's gone up by +1. So see, this one deals with shifting up or down. Now the tricky bit is how much did it move to the right by or left? So that's the x minus b. So let's just have a think about this. Typically, if you're going to do it normally, if this was the center, then it would have started from here. And it would have gone up to 90, and then back to 180, and then down to 270. So remember, -1 is the base, 1 is the center, and 3 is the height, and back to 360. So just look at the distance now. You can see from here to here, it's gone from 90 to 180. So it's a 90 degrees change. From 180 to 270 is another 90. And from 270 to 360 is another 90. So that's it. So B must be 90 degrees. Okay, number 19. So Jack plays a game with two fair spinners, A and B. So with A, it can land on 2, 3, 5, or 7, whereas B can land on 2, 3, 4, 5, or 6. Now Jack spins both spinners, and to win the game, one needs to be odd and the other needs to be even. So that's the aim. And one spin has to be odd and the other has to be even. Now Jack plays the game twice. Work out the probability that Jack wins the game both times. So in order to do this, we just need to work out all the possible outcomes he could win. So the only way he could win is that if he got an odd first time with spinner A and even with spinner B, or he got an even with spinner A or an odd with spinner B. So remember, this is just an outcome for the first game, yeah. So let's have a look at the probabilities. So to get an odd in the first spinner, you have how many options? You got 3 and 5. So that's 2 out of, no, also 7. So that's 3 out of 4. So you're at 3/4, and always put times because you're doing this all at the same time. And to get even in B, you got 1, 2, 3. So 3 out of 5. So that's literally the probability for that. Whereas if you got an even in the first game for A, even for spinner A, it would be just 1 out of 4. And again, to get an odd for spinner B, it will just be 1, 2, and so that's 2 out of 5. And that's it. So literally just work this out. And what do we get? So you get 3 times 3 is 9, so 9 over 4 times 5, 20. Whereas this is 2 out of 20. And because you got two different options, you have to add this up. So this will give us a total probability of 11 out of 20. Now, this is only the probability of winning one game. So you have two options to win one game with 11 out of 20 chance to win. But if he's going to win twice, well, you just have to do this twice. So winning the first game and winning the second game, it needs to be at 11 over 20 times 11 out of 20. And that's it. This is literally the final outcome. And I'm multiplying this out, well, you should get 121 times 400. Or, you know, I'm actually doing this mentally, so hopefully this is right. But anyway, guys, that's literally it for 19. So let's move on. Ooh, and here we are, guys. The final question, number 20. So let's do this. ABC is an isosceles triangle. So quick recap, isosceles simply means two lengths are the same. So they'll probably give you one length. So we have to realize our length is the same. Such that AB equals AC. So this means if we call this one A, we can call this one B. So AB equals AC. Okay, so two identical lengths. Such that A has coordinates 437. So label that there. And B and C lie on the line with equation 3y equals 2x plus 12. So we just got to imagine that this is a straight line with equation 3y equals 2x plus 12. So we keep in line with this, yeah? So we can eventually work out the gradient and whatever we need to do. Yeah, and yeah, so find an equation of the line of symmetry of the triangle. Ooh, so that's an interesting one. So line of symmetry is down here. Okay. And yeah, just quick note, if this is a line of symmetry, that means we have two perpendicular lines. So that could be useful for a second. Give your answer in the usual form. All right, cool. So let's do this. So how do we start with this? So what I would personally advise that since we got a coordinate here, which is on this perpendicular line, and we got a line already here, we should go ahead and find the gradient of this line. And to do that, we need to rewrite this in the usual y equals mx plus c form, where m is the gradient. So far it looks to me that it's almost there. We just have to divide this equation by 3. So we're going to have y equals 2 over 3x plus 4. So this means the gradient of the line that cuts through BC is 2 over x, but the perpendicular gradient of the line from A downwards is going to be the reciprocal negative, the negative reciprocal. So we can say that the line going downwards is going to be y equals minus 3 over 2x plus something, which we don't know yet. So we're actually almost there. We literally just got to find c. But it's easy now, because since we know that there's a coordinate on this line, that 437 is on that line, we just plug in x is 4 and y is 37. So let's do that. Plugging in 437 when y is 37 and x is 4. So it'll be 4 times 3 over 2, which is minus 12 over 2 plus c. And looks like we're done. So minus 12 over 2 is minus 6 plus c. So the purpose is to find the c value, and then we can rewrite in that usual form. And now we just add 6 across, which is going to give us 43. And yeah, that's our value for c. Now putting it back in the usual form, so we've got y equals minus 3 over 2x plus 43. And the form they want us is in integer form, where p, q, and r are whole numbers. Yeah, so integer means whole numbers. To do that, just clear the fraction, so times by 2 across. We're going to get 2y equals minus 3x plus times 43 by 2, and you get 86. And they want in px plus qy form, so we got plus 3x across. So we're going to have 3x plus 2y equals 86. And that's it, guys. That's literally the end of the paper. Whew. So I hope this helped anyway. I mean, if you guys got any questions or any problems, let me know. I mean, this final question I think wasn't too bad. I mean, if I got it wrong, then, you know, lol. But anyway, guys, I hope this helps, and please check out my other videos. Leave a comment, subscribe, share with your friends. But otherwise, I shall see you guys in the next ones. Ciao.